Oh, try not to fall asleep. Yes. Mood lighting. Okay. Naming angles. You guys with me?
Is that an acute angle?
It is. Okay, now,
Yes.
when I say, all right, however, that is how you would classify that angle. That is an acute angle. But if I wanted to name that angle, like I could classify all of you as students, but that's not your name. Okay, your name is not student. How could I name that angle?
PQ.
Free, go ahead.
The letter names?
Yeah, like this. How would I name this angle?
The PQ.
Okay, so I could name this angle PQR. Okay, what's another way I could name it? Because there's another way I could name that same angle. Steven?
Angle RQP.
Good, angle RQP would work as well.
Good job.
What about angle RPQ? What are your thoughts on that?
No.
Why not?
Does it have to be QP or?
Okay, because you have to follow those letters in order. So angle RPQ would mean to go from R up to P and then down to Q. So if you were talking about this angle, that would work. Okay, but we're not. We're talking about this angle. So this is not an option. Okay, you do have to be careful about that. Because this is just a single angle, this is a really simple single angle picture, there's a shorter way that we could name this angle because mathematicians are lazy and 3 letters is pushing it. So how else could we name this angle? Which is a single letter. Okay?
Q.
Angle Q. Yeah, I could just call it angle Q, which is the vertex of that angle. Okay? So when it's just a nice simple angle, you can just name it with a single letter. However, look down at that next picture. Let's say I was trying to name this angle right here. Could I get away with just calling it angle B?
No.
Why? There's a whole bunch of them that have B as their vertex, right? B is the center of all of those angles there. So when you have a picture like this one, or something like even down here, I couldn't get away with just calling this angle A, because there's this angle, and there's the bigger angle here. Okay, so when you have a lot going on in your picture, you do need to use all 3 letters. How would I name this angle here? It's got that one. Clay, go ahead.
Wasn't there like 2 ways?
Yep.
BD or DB.
There you go. DBE. What's another way I can name that same one? Brooke?
EBD.
EBD. As long as you keep that B in the middle. Okay? But like I said, mathematicians are lazy and sometimes 3 letters is pushing it. So sometimes they do this for you, which is really nice. They take the angles and they number them. And that way you don't have to spend a lot of time saying from this letter to this letter to this letter. You can just say angle 1 or angle 2. However, what if I wanted to name this whole angle? Then I would have to break out the 3 letters and I would have to say angle BAC. Okay? Does that make sense? Nothing earth-shattering there, right?
No.
Okay, angle bisector, and you probably do have to write down this definition, is a line, a ray, or a segment that divides an angle into 2 congruent parts. So it cuts the angle in half. Basically, that's a fancy way of saying this line cuts the angle in half. What if I told you that the measure of this angle was 34 degrees? What would the measure of this angle be? Not 21. You have to be careful not to use that number. What would this angle be? If this is a bisector. Brett? 34. Yeah. Yeah, this angle would also have to be 34. Okay, what if I told you, let's get rid of those. Oh, that one's not going to erase. What if I told you that this angle was 46, and I wanted to know what this whole angle was. What's that, Gavin? Okay, add what? Okay, because this one would have to be 46 as well, right? So we would double that 46. 46 and 46 would make 92. Okay? What about if I told you this whole angle was 7, we'll go straight up 70. 70 degrees. The whole angle is 70 degrees. What are the two smaller ones? Yeah, divide by 2. So 70 divided by 2, each one of the smaller ones is 35. So you're going to get questions like that. You just have to know how the bisector works. The two smaller ones are equal. Add them together to make the whole one. So let's look at this. We know that AB is a bisector. So we know that this cuts it in half and these two pieces are equal. It says angle CAB is 5x minus 11 and angle BAD is 2x plus 25. Before we even start here, I'm going to go ahead and put those measurements in here. So angle CAB is 5x minus 11. And angle BAD was 2x plus 25, is that right? Okay. And I want the measure of angle CAD, which is the whole outside angle. Now some of you might be looking at that and saying like, all right, let's just combine those. And it would be 7x and then this would be 14. So 7x plus 14. Well, you've got the right idea, but we have a way that we can actually figure out what x is. So we need to do that first. Any thoughts about how we could figure out what x is equal to? Clay.
2.
How'd you get that?
How is every, like, this, the 2x.
Okay.
7x equals 14.
Okay. The problem is if we added those together and got 7x plus 14, that's not the same thing as 7x equals 14. Okay, we don't have, if we added those together, we would have 7x plus 14, but we don't have anything to set that equal
So you
to.
just do equals 14 then?
Nope, it's not equal to 14. We got to do something else that's equal to each other. Carly?
Like 5x minus 11 equals 2x plus 5.
Right, these two must be equal to each other, right? So what I'm going to do is I'm going to set up a problem. Let me give myself some space here. And I'm going to say, I know that 5x minus 11 has to equal 2x plus 25. What do I do to solve that from here? Clay, you got it?
Yeah, just, you can add 11.
Sure. Yeah, let's add 11. So 5x equals 2x, and then 25 plus 11 is 36. What now?
Subtract 2.
So subtract the x's. So subtract 2x from each side. And I get 3x equals 36. So x would equal what? Whoops. Yep, divide by 3, you get x equals 12. Now, does that answer our question? That tells us that x equals 12. How does that help us get the whole angle? Okay, so let's plug it back in. Blow this back up here. So here, this would be 5 times 12, which is 60, minus 11, which is 49. And this would be 2 times 12 plus 25. That's 24 plus 25, which is 49. Is that what was supposed to happen? Okay. And someone second hour actually pointed out, like, why would you have to plug it in twice because you know they're the same? You're right, that you would know it was the same. So you should only have to plug it in once. I usually plug it in both places just to make sure it does come out the same. Because if it doesn't, then I made a mistake. Okay? But that gives me my, that tells me each of the smaller angles is 49, so then what would be the whole angle measurement? Because the question wants to know the measure of angle CAD, which is this whole thing. 98, yep. So you could do 49 plus 49 and get 98. Does that answer bother anybody?
Yes.
Blake?
That'd be an obtuse
Okay, so looking at that picture, that is not an obtuse angle. all right? Which is a perfect segue to what I want to talk about next. That is the right answer, by the way. Clay? Well, I did. That's what the 49 plus 49 was me adding the two angles together, and that's where I got the 98. This is why they let me keep my job teaching geometry, okay? Because there are certain things you are allowed to assume from looking at a picture and certain things you are not allowed to assume. These are sort of the rules of the road, okay? And I'm going to jump actually down to this one right here. Anything marked, you have to assume, no matter what. Okay, even if it's a terrible, terrible drawing, and you're going to see some terrible drawings sitting in my class. Okay, but if I draw it and then I mark it a certain way, you have to believe me. That's why I get to keep my job teaching geometry, because you have to believe me. Let's go back up to the top. Collinearity. Does anyone remember what that word means? The same what? Together on the same line. Yes. So what this is saying is I can assume points are collinear if they are all drawn on a line. So if I draw the line between them, it's okay for me to assume that all of those points are in a line. What is not okay for me to assume is if I have 3 points drawn and they are not connected with a line. If they are not connected with a line, I can't assume that they lie in a straight line. Okay, even if it looks awfully close. You can assume that lines intersect. So if I draw two lines like this, you can assume they intersect in that point right there. Points in the interior and exterior of angles, that means that if you have an angle like this, we can assume that point is on the inside of the angle. We can assume that point is on the outside. And then again, this is my favorite one. Anything that's marked, you have to believe me. So if I draw an angle like this, oh, actually, that's too good. If I draw an angle like this, and then I put this little thing in the corner, what do you have to believe? You have to believe it's a right angle. That's right. Okay, if I draw that angle like I did on the last slide and you solve and find that it's 98 degrees, you have to assume that it's 98 degrees, even if it doesn't look like it. So you can't tell from looking at a picture what the angle measure is supposed to be. Now, if you looked at that and said, hey, wait a minute, that's supposed to be obtuse, I'm glad you're making that observation. But just know that the picture might not always match. Okay? Back to things you can't assume. You cannot assume that lines are parallel. So if I draw two lines like this, you cannot assume that they're parallel unless they're marked as parallel. Okay? And we'll talk about the marking for parallel probably tomorrow. Exact angle measures. So you can't look at an angle and say, oh, that looks like it's about 72 degrees. All right? You can't do that because they're not specific when you draw them. And then you also can't assume that things are congruent unless they're marked as congruent. So even if I have like two angles that look an awful lot alike, you can't assume that they're equal to each other unless I mark that they're equal to each other. Or unless we have some theorem that says that they're equal to each other. Does that make sense? So just kind of laying that out there for you. Be careful about what assumptions you're making off a diagram. Okay, some words for you, and probably all you have to add into your notes on this are the pictures. Okay, because we have talked about almost all of these already. Acute, right, and obtuse, I'm assuming you guys are pretty good on, right? Acute, right, and obtuse angles. A straight angle. A straight angle is an angle with a measure of 180 degrees. What's another word for that? A line. Yeah, if it has 180 degrees, it must be a line. And then a reflex angle is an angle that opens wider than 180 degrees. So it goes flatter, it goes to a straight line and then keeps going. I don't know if you can picture this from here, but if you started here and then spun like this, that's more than 180 degrees around. That's called a reflex angle. It's almost like the outside of one of these angles. Okay. Once you get your pictures drawn there, make sure you mark like that the right angle is a 90 degree. Words for you that again you've already seen. Complementary and supplementary. Complementary, you need to know they add to 90. So as soon as I say these two angles are complementary in your head, you should be going, oh, that means they add up to 90 degrees. Okay? Complementary and supplementary always refer to a pair of angles. You're never going to have just one angle that's complementary. I get that answer a lot. What do you know about that angle? Oh, it's complementary. That angle by itself can't be complementary. Okay, complementary refers to two of them. Got those pictures down okay? Okay. All right, some pairs of angles. These are important. Adjacent angles. What does adjacent mean again? You remember adjacent? Next to. Yeah. Adjacent means next to. Two angles that are next to each other. They are next to each other and they share a side. So see how they have this side in common? That makes them adjacent angles. Linear pair is a special kind of adjacent angle. It's it's a pair of adjacent angles where the sides that they don't have in common. So here's that side that they do have in common. The sides that they don't have in common make a straight line, which means they add up to what? 180. Yeah. And that means that those two angles, what else could we say about them? If they add up to 180, they must be supplementary. So every linear pair makes supplementary angles. And then vertical angles are angles opposite each other formed by intersecting lines. So like 2 and 4 here are vertical angles. And then we also know that 1 and 3 are vertical angles. Okay, so these are angles that they share a vertex still. They still share that common point in the middle, but they're not right next to each other. They're across from each other. Vertical angles. Questions on those? Before we do a couple more examples. Okay. So, an angle is 1/4 the measure of its supplement. Find the measure of the angle and check your answer. Okay, this is a tricky one. I'm going to guide you through this. Make sure you're writing this down so that when you get to this problem in your homework, you can follow this example. I'm gonna get a little algebra-y on you, okay? So I have an angle, and then I have its supplement. By the way, what word does that sound like? Supplement. Where does that come from? Supplementary. Good. The supplement of an angle is like the angle that makes it add up to whatever it's supposed to add up to. Like for supplement, it would be the angle that would add up to 180 with another angle. So if I had a 30-degree angle, what would the supplement be? 150, right? Because 150 and 30 make 180. If I had a 100-degree angle, what would the supplement be? 80. Okay, so that's what I mean when I say supplement. So my angle and my supplement need to add up to 180. Okay? My angle, I don't know what it is. I don't know what it's equal to. What do I use in algebra when I don't know what something's equal to? X. Okay, I'm going to use a variable. So then what would the supplement be? I wouldn't want to throw another variable in there. That's going to make this too hard. Think about this. When I was throwing you those numbers a second ago, when I said a 30-degree angle, what did you do to get 150? Keegan, do you know? Okay, so what were you going to say about the supplement, do you think? Okay, coming from this problem, I see where you're getting that. Hold that thought for just a minute. So we need to subtract from 180, right? So when I gave you 30 and you gave me 150, you did 180 minus 30. When I gave you 100 and you gave me 80, you did 180 minus 100. What are you going to do, Clay?
Well, like, just do 180 divided by 4.
That's not going to get it quite. I see where you're getting that from. It's not quite going to get there. I'll show you why in a second. Hold on. Before we're even talking about this problem, just in general, if I have an angle with a measurement of x, what would I do to find its supplement? What did you do with the 30 and the 100 that I gave you? Brett?
Would it be 180 minus x?
That's what I was looking for. Yes. So the supplement would be 180 minus x. Okay? So whatever my angle is, 180 minus x will give me my supplement. Okay, now I want you to look at this. An angle is 1/4 the measure of its supplement. I'm going to set that up word for word as an algebra equation. So what are we calling my angle again? X. Is always your equal sign. Okay, and I know you haven't had our algebra class yet. We spend a lot of time talking about that, but the is your equal sign. So an angle is 1/4 of the supplement, and the supplement is 180 minus x. So here's what your equation is going to look like. Okay, so you have one angle here, and then this is 1/4 of the supplement here, and we know that they're equal to each other. So I'm going to rewrite that down here, and we are going to solve it, as fun as that sounds. I'm going to say x equals 1/4 times 180 minus x. Okay. Here's what I would do with something like that to solve it. And again, I don't know if you've seen this as a strategy for equation solving, but what's the scariest part of that equation? Oh, I'm not scared by the x. I'm scared by the fraction. Okay? How could I get rid of that 1/4?
180 bucks.
Not divide. Okay. I could change it to a decimal, and the decimal would make it less scary. What I would probably do is multiply by 4 on each side, because what's going to happen when I do 4 times 1/4? It's going to disappear, right? 4 times 1/4 cancels out. So now I have 4x equals 180 minus x. And that, I think, Keegan, is where you were getting 4x from. Okay? Is that the supplement, if the angle is 1/4 of the supplement, then the supplement is 4 times the angle. How would I solve from here? Okay?
I was going to say add x.
That's what I would do. Yeah. Let's add x to each side. So now I end up with 5x equals 180. And this, Clay, is why you couldn't have divided by 4. You would have had to divide by 5. Because you've got an angle taking up one piece, and then another angle that's 4 times as big. So altogether you really have 5 pieces of 180. Does that make sense? That if you just divided by 4, you would have one angle with a 1 and one angle with 3.
What I was saying was like, you divide by 4, then you can find out how much 1/4 is, and then subtract from 180.
Except there's not really 4 pieces in play here. There's 5. Let me show you that, and I'll draw a picture for you in a second. But so 5x equals 180, divide by 5, and I think you get x equals 36. So our angle is 36 degrees. What would our supplement be then? $144, yeah.
Wait, how do you get the supplement?
Oh, I did 180 minus x, so 180 minus 36. Okay? So that would be 144. There are some other ways you could have tackled this problem. Like I said, Clay, yours was really close. Here's the thing with yours, is you have an angle. So you have this, right? That's my angle. And then you have another angle that's 4 times as big, right? Because if it's 1/4 of the supplement, then the supplement must be 4 times bigger. So I would have 4 times as many pieces of that 180. Do you see that altogether I really have 5 pieces that have to make up that 180?
Yeah, but I don't get with 1/4, there's only 3 left, so.
So if I took that 180 and broke it into 4 pieces, okay, can someone help me? What's 180 divided by 4? 45, yes. Okay, so 180 into 4 pieces would be 45, 45, 45, 45. So if one of the angles was 45, and then the other angle would be 135 is what those 3 would be. But is 135 4 times as big as 145? I'm sorry, is 135 4 times as big as 45? No, it's only 3 times as big, right? because you only broke it into 4 pieces to begin with, and one of those pieces had to be your original angle. So that's why you need 5, because one piece is for your original angle, and then the other 4 make it 4 times as big. Is that what you would have come up with doing it your way, 45?
Yeah.
Okay. Yeah, that's why, is because you're breaking it, you've got to have a piece for the angle and a piece for the supplement, and you want the supplement to have 4 and the angle to have 1. Okay? Try some more tonight and maybe it'll help. Oh, how am I going to get rid of this junk now? All right, let's try the next example. Next example is a lot easier. If I can get rid of this mess. There we go. Okay, suppose 1 and 2 are supplementary and adjacent. Hey, there's a name for that. What do I call it if they're supplementary and adjacent? Oh, I see someone's looking back. That's right, linear pair. A possible diagram. If they're adjacent and supplementary, they must make a straight line, right? So there they are, supplementary because they make a straight line, and adjacent because they share this side in the middle. Angle 1 is 60 degrees. So how do I find angle 2? What's that? This is a whole new problem. No 4s involved now. Maddie?
Subtract 60 from 180.
Yeah, I know they have to add up to 180, so 180 minus 60 would be 120. Okay, simple, right? Hopefully. Okay, if angle 1 is 43 degrees, what is angle 2? Excuse me, I'm sorry. Go ahead.
137.
Yeah, how'd you get that?
43 minus 180.
Yeah, 180 minus 43 equals 137. So angle 2 would be 137. Now the part we struggled with first hour, or second hour, part B is a totally separate question, so that 43 is not there anymore. If measure of angle 1 is equal to x, how would I get the measure of angle 2? Think about what Clay just did a second ago. We said this earlier. Yeah, 180 minus x. That's it. And you would just leave it like that. 180 minus x. Final answer. Good. And the next one. All right, now I have to warn you. I taught you something earlier than I should have. Darn it, for giving you more information than what you're allowed to have at the time. Pretend you know nothing about vertical angles yet. Okay? 62 degrees is that one angle. Somebody tell me how you can find another one of the angles here in this picture. Brooke.
Put 62 in for number 2
Okay, how do you know that?
because it looks the same.
Okay, first of all, we can't go by how it looks, but you are right, they are the same. But we don't know that yet because I taught it to you when I wasn't supposed to. So pretend, not that I wasn't supposed to, but I taught it to you before we proved it, which we're going to prove tomorrow. So you are right, they are the same, but pretend you don't know that yet. Somebody tell me something else. Yep, Gabby.
You could take 62 and angle M, and then you could subtract 62 from 180.
Okay, so which angle were you looking at to get from that?
1.
1. Okay, so this line we know is 180, right? So we could do 180 minus 62, and that's going to give me 118. Okay, so angle 1 would have to be 118 because of that 180 degrees. Now look at angle 2. Any thoughts on how you could get angle 2 now? Ben?
Now that we have 118 degrees for angle 1, we can do the same thing.
Yeah, look at this straight line. So 1 and 2 would have to make 180, right? So we could do 180 minus 118. And lo and behold, that brings us right back to 62, which is what I just told Brooke she wasn't allowed to know a minute ago. Okay? And then how would we get angle 3? Yeah, this is a straight line again, right? So 2 and 3 make up that straight line, so we must have to do 180 minus 62 to get, I have no idea, what would it be? Good.
17.
Suspense is killing me. What are all 4 of those going to add up to, by the way? 360, yeah. So when you add all of the angles going all the way around, it should always equal 360. So sometimes that's helpful too. Okay,